Very welcome to another session of C++ programming. Today we are going to discuss chapter 7, which is focus on pointers. So we are going to look at creation of a variable like any other regular variable that we used to practice during the course, but the difference in here is so far we never know when we are creating a variable, that variable is going to be stored in what location. We do not have option in programming to assign a certain location for the variables or any other information that we are providing to the software. For example, we cannot say, okay, go be saved on address 12345 or whatever, with maybe some letter. We never do have such an option to specify the address or the location of the variables that we are defining in programming. But also we cannot ask the computer to go just maybe book that certain address or that certain location of the RAM for us, for example, to store variable num in this example. Still, after it is randomly stored, so any variable that we are creating is going to be randomly stored in a location. But as soon as it is done, it is stored in some location in the RAM, still we do have option to call the location. So we cannot assign the location, but we can get access to the address of that memory or that, let's say, variable, right? So how do we do that? Process of defining the variable is as regular. Like, for example, as you can see in here, I'm defining a variable called num, and I'm storing some numbers in this variable. And now I need to find out what's the location that this num or this variable in here is stored. In order to do so, I do have one option, which is going to be address operator. So you need to hold the shift and or number 7 on the keyboard. Most of the keyboard is number 7. If you hold shift and number 7 on your keyboard, it is going to give you the address operator. You may know it as AND, but here we call it address operator. Exactly what I am highlighting in here is one AND, right? But in here it is acting as address operator. So anytime I need to print out the address of any variable that I have defined, I simply need to say cout as a regular command, and then I need to say and right after the and or right after the address operator, I can use the name of that certain variables. So as soon as I'm giving you more information, definitely we can go ahead and practice getting access to some variables inside Visual Studio. So now let's look at pointer variables. When I say pointer, remember I said if I'm going to get access to the address, let's do, for example, int num, and I'm going to assign it to a certain number. It could be just whatever, let's say 45 or whatever. And now I don't know what's the address. I simply say cout. You may want to practice with me. And I use address operator num and semicolon, right? Now, what will happen if I debug? I can debug, right? Because I don't have any error, nothing. All I may see is just some address, which could be a combination of some numbers and some letters, which is going to be in hexadecimal or in hex or hexadecimal. So give it a second, and then you can see, you can find out what's the address that your variable has been stored. Like, for example, in here, you can see here is the address. It's a combination of, I'm going to maximize to ensure everybody can see. This is the address in the memory of the computer. Although I was not able to assign it, like, for example, customize it, but I can read the address. So this is the address that this num is right now for me stored. So now let's look at the pointer variable. Pointer is a variable which is, as I just said, which is going to hold some address for you. My variable is num, and num is like, for example, in a certain address. Now, in case I need to just change information inside num, I have to make it a variable, a pointer variable. So pointer variable can hold the address of another piece of data, which is, for example, if I'm going to send like 45 to num, 45 is going to be stored in the exact same address that num as a variable is stored. Let's say, for example, in here, now I'm going to look at some reference variable. Reference variable means I'm going to first define a variable such as num, assign some information to it. Later, I'm going to just reference it, right? So that's what we call it, reference variable. So remember, we learned how to create a function. In this example, I'm going to just specify it for you. For example, I'm going to create a function, call it getOrder. GetOrder has some arguments, and the arguments in here include one data type, address operator, and one variable called donut. So I'm having an integer with donut. What I'm going to do, I'm going to ask how many donuts I want. Either you can just have it as a hard coded inside the code, or you can see in the number of donut. But we can later call it with some reference. This is what we call it, reference. We can say, for example, I'm having some jelly donut, which is an integer, and I'm gonna receive the jelly donut because jelly donut is going to be stored in the same address as donut. So jelly donut is in the same address as donut because I assign them to each other. So that's what we call it, reference variable. It is going to be stored exactly in the same variable location, which is the donut. Like in here, for example, I'm having an address for the jelly donut. This is a function, right? I'm having an address for the jelly donut. Jelly donut is a variable, and the address of this variable is the address of the initial variable, which was donut. Now, pointer variables is looking at the memory address, some location that the variable is going to be stored. Why we need it? The first reason for why we need to get access to the location of a certain variable is there are situations we define a variable and later we want to define another variable. Somehow we want to replace this variable with the other one. There are two methods. If you wanted to do it without pointer, we have to define the variable two times. Simply means, let's say I'm having num, and then later I'm gonna have maybe count, and then count, maybe I want it to be maybe 65. In this case, I am going to hold two different addresses. For each of these variables, I'm having a certain address, one for num, one for count. Therefore, I'm gonna occupy more memory space. I'm gonna make my computer more busy. The RAM is gonna be kind of less RAM for other aspect of my work. But there are situations I can have it like as a pointer. If it is a pointer instead of just borrowing two memory location, I can send the new variable to the exact same location as the initial variable. Then I don't need to borrow two space from RAM. That's one of the benefits that we can get from pointer. We can define one variable first in a certain location, and without removing that location or without borrowing more RAM for another variable, we can create another variable in the same location. Means we can replace the initial variable with another variable. That's one of the reasons that we need to learn how to use pointer. Let me say, for example, I'm going to define a pointer variable. I already said num. I'm going to remove count for now. Another important thing that you need to learn about it. In case you are going to define a variable as pointer, one of the initial things that you need to know is a symbol or syntax for pointer, which is asterisk. Anytime you see an asterisk before your variable, you can simply recognize this is a pointer. So do not confuse this with address operator. Address operator, which you can see it right in here, is going to give you only access to the location of that variable. It doesn't turn it to pointer. It's just calling what's the address of the variable where it is stored in the RAM. But pointer, which is like the asterisk, is going to define that variable as a pointer. Simply means later you can change the information inside this variable, which is assigned to become a pointer variable. So now, what is this asterisk num or pointer variable, which is a num, going to do for us? Here I'm using similar example. Instead of num, I'm calling it int ptr. Ptr is standing for pointer, int standing for integer. Means I'm just having an integer to become a variable, and I'm gonna turn it to pointer. This variable is going to have an address. Is going to be first integer because I assigned the data type integer, and it's going to have an address. So now, if I define it as asterisk with no space with num in here, this is correct. If I define it with integer, asterisk, some space, then num, still you're not gonna get error. Still it is correct. So it doesn't matter if you just include some space in here or no space. Both of them are going to be correct. So having a space, it won't give you any technical concern. That's one thing I need you to definitely learn. Now, I can just define it. I'm going to remove this. I can define my variable as a pointer, and later I'm going to say, I'm going to have like the same variable. In my case, is num. If I do have another variable, I'm going to assign it. I'm going to use address operator and assign it to, like, for example, another variable. Remember, I created count. I'm going to do count again. I'm going to assign it to a different variable. So first I define it, and then I just take that one and I assign it to a different variable if I do have another one, for example, int count. So simply means I'm going to just store both of them in the exact same location. So I get this one and I assign the new one to the same location. So this is what we call it, assign an address to a pointer variable. Assign an address to a pointer variable. And I already told you how to get access to the address. Just simply include the address operator before your variable. Let's look at this piece of code together. You may want to just create your template and start coding with me. I'm going to clean up here and I'm going to practice one simple example to give you a better understanding of how to use pointer in C++ programming. So this program is going to store the address of a variable in a pointer. Like always, we start with hash include iostream. Definitely use using namespace std. Start with your main function, and then right in here, start defining your variable. Do this simple practice with me to ensure you can see the functionality of the address operator and pointer properly and remember it for later use. So I'm going to define an integer. I'm going to call it x, and I'm going to assign my number, my x to number 25. So this is my integer variable, just x, y, whatever name, that's totally your option. Right after that, I'm going to define a pointer. Remember, this is a regular variable. How do I know? Because I do not have an asterisk before the variable. This is a regular variable, and now I'm going to go ahead and define a pointer variable. So I say integer asterisk. I'm going to call my pointer variable ptr, and I'm going to close it with semicolon. So now this pointer variable can actually point to an integer only because the data type is integer. Okay, that's the reason. Now I'm gonna say I'm gonna store the address of x because I already defined x. X is going to immediately borrow some space in the memory. So now I'm gonna go ahead and store the address of x in PTR. Very similar to what I did earlier. So I'm gonna say PTR assigned to address operator x and then simply semicolon. Now address of x is stored in PTR. Now I can go ahead and find out what's the value of x. So I would say cout, excuse me, and I'm gonna say like x is, and then I'm gonna go ahead, read the x, and you can simply say and so now simply I can read the x, which is going to be 25. And I'm going to also cout the address of x. So I would say now x is 25 and the address of x is, now address is stored in PTR. Definitely I have to say read it from PTR and then endl. So I already define one regular variable, then I define another variable as a pointer, and then I store the address of the regular variable x in the PTR as the pointer variable. And now I'm gonna debug and see what console is going to show us. So definitely it should give me first x is 25 as you can see on my screen, and then the address is like a combination of some numbers and some letters, and I have no option to adjust the address. So this is how do I define some regular variable, then how do I define a pointer variable, how to store address of the regular one in a pointer, and how to get access to both of them. Hopefully it's clear for everyone. If any question, feel free to ask. So let's go back to the lecture note if no question. Now let's look at some other operators, like for example, indirection operators. Remember I said indirection operator is like the address operator, or like asterisk, right? So indirection is going to help you in cases that you are going to point to a certain pointer. Like for example, in here I said X and PTR, right? Now, as you can see in here, asterisk int PTR, this one is going to print 25. If I say asterisk in PTR and I assign both of them, it's going to print out like 25. And I don't have anything in PTR. I just have something in X, and this is what I call it. Indirection operator means I just assign some information in the first one, and then using address operator, I get access to the information stored in the pointer, like what I do in here. So I already stored the data like inside the X. I just read what is X, what's the address of X. I can just add one more line in here just for practice, and I can now go ahead and cout like asterisk, just asterisk PTR, asterisk PTR, and simply and down. Very similar. This one is going to display the content of X. Also, I already said what is X. So this is one method to say what is X. Another method is just say asterisk PTR. This one also is giving you the content of X. Let's go ahead and assign also maybe some information to the PTR, like for example, since I already didn't have anything, I'm gonna give it maybe 90 or whatever. Now, if I assign 90 and go ahead again, right after that, say display or cout, again asterisk PTR, then the information should be context, still content of X, not content of PTR. So I'm gonna again say PTR, see the difference right after this, and I'm gonna just add some NL in here. So first, I'm gonna display the contents of X. Either you can say what is the X, like what I said in here. What's the address of X? And then I'm assigning 90 to X. 90 is going to be stored in the location of PTR, where the PTR is. And then I'm giving it some information. And then again, I'm gonna ask, what is X? Maybe one more time. Cout first X, cout X, and then cout PTR. Let's see what will happen. It should give me first 25 and the address for that, as you can see right in here. X is 25, the address is this one. Look at here, and then I said assign PTR to 90, and then cout the 90. So you can do it either this using this method, or you can simply just do it using this method. Both of them is going to give you the information stored in PTR. Next, let's look at how to initialize a pointer. In this example on my screen, I defined two different variables. One X, which is a regular variable, and next PTR, which is a pointer variable. Since both of them are integer, there are two methods to define them. Either you can define in a separate line, or you can just simply just have this one to be defined exactly where the other one is defined. You can say num or X, then comma, and assign whatever you have as, like for example, asterisk PTR as an pointer. There's some delay in my screen for some reason. Let me fix that. Okay. So, and then right after that, go ahead and close it with some semicolon. So this is how you can initialize your regular variable, then assign the address of it. Even this one could be done in a single line. Instead of having it like in here in a separate line, I can remove that and right in here I say, okay, now I'm gonna assign both of them to the address of X. That's another method in order to just compact your coding. I did this simply because both of the variables, it was just integer, but there are situations, one of your variables is integer and the other one is double. In that case, you cannot combine them like the method that I did. In that case, if your next variable is like, for example, like in here, it's like a double, you must just leave them separate. You cannot combine the two variables not following the same data type. You have to make sure this will give you error, so never do that. So just do separately. Now let's look at how we can compare two pointers. Suppose that we have multiple pointers. Can we compare the information inside those pointers? Let's do that. Suppose I have both of them, both X and PTR to be pointer. Or you can see on this example on my screen, I do have PTR1, PTR2. All right, in here I created one integer and one double, both of them pointer. In order to compare the address, like the information inside them, we can use some mathematical operators, such as, look at my screen in here. If I've got two actually variables, just regular variables like pointer 1 and pointer 2 in this screen are regular variable, I can say as they are equal. If I do have two equal sign, means equal, means this is a mathematical operation. But if I have only one equal sign, means this one is assigned to that one. It might be equal, it might not be equal. But when you do have two equal sign, means any information in here is equal to any information in here. So we can do exactly the same thing for the pointer, but with one difference. If they are two regular variables like ptr1 and ptr2, and I like include equal sign in between them, I'm going to compare the address of these two variables, not the content. Don't get this wrong. So in this case, they are not pointer, they are regular variable. Only the address of them can be compared. But in cases like here, since both of them are pointer, if I put like equal sign in between them, the content of them will be equal, not just the address. The address could be two different addresses, but the content, as you can see in here, content is going to be equal in case they are pointer. For example, if this is 25, this will be 25 as well. But in this case, if this is 25 and this is maybe 35, still they could keep whatever data and information they used to have, only their address could be equal. That's the thing. That's the difference between comparing the regular variables and comparing pointer variables. Now let's look at pointer as a function parameter. What do I mean when I say function? Remember, we had this information about how to create a function in chapter 6. Entire chapter 6, it was focused on how to define a new function, anything extra or anything in addition to your main function. Now we are going to have that certain extra function that we are going to focus on as a pointer. Well, we can never define a function name, or let's say header line or first line, like for example, void maybe gets num. We don't turn the get num as a function name to become a pointer. We can define the pointer for the function inside the argument. Simply means I can still say integer. I'm defining the parameters of this argument, and I can define, for example, asterisk ptr1. So that's how I turn a function to a pointer. So not the name of the function, the argument of the function. And then I can go ahead and define maybe any information inside the function. And in case I'm going to, for example, create my prototype, I simply copy the first line, or let's say the header line of the function. I move to the beginning of the code, I paste it, I add semicolon, and I must remove the variable, but I must keep the asterisk. Asterisks must be included in the prototype as well. I cannot remove the asterisk if I do have one in here as a pointer. I only can remove the variable name inside the prototype. Pay attention, this is important. I see many times students are just creating the prototype. The actual function, argument of the function is a pointer, but they forget to include the pointer symbol or the asterisk inside the prototype, and that's giving you some mistakes. And in case you are going to call the function somewhere, maybe for example here or anywhere, in case you are calling the function, still for calling the function, you must include the asterisk. You must make sure that this function initially was a pointer. So for example, in here, if you want to cin, you have to cin the ptr, but ptr is a pointer. Since ptr1 in here is a pointer, then in here I have to say cin asterisk. PTR1, for example. I cannot ignore I haven't called the function yet. That's why it is underlined red. So let's look at another example to practice all of this together. I'm going to clean up this and I'm going to start another new example to ensure you can get enough practice on how to define a function, which is a pointer. So far, I'm going to first start with just an integer like num or number or whatever. This is my regular variable. And then I'm going to call another variable, which is going to be my actually function. So I have to first go ahead and create a function. In here, I said num. In here, I'm going to say get num integer. And instead of ptr1, I'm going to say maybe another variable as input. Once again, it doesn't matter if you have a space between the data type and asterisk or you do not. Even between asterisk and variable, no space is like correct. Including a space is also correct. Either could work. So I'm going to first define my function, which is a pointer. And I'm going to say in here, just see out probably maybe some message in here, just for practice. Like, for example, since I have input, enter a number, enter a num, maybe simple. And I'm going to have a colon. And then either you can use endl or you can simply close it. And now I'm going to say cin. Look at here, input is a pointer. When I say cin, I must say asterisk input. Otherwise, I'm going to get error. So I already defined one function, which is a void function. And this void function is just going to give me option to cin a number. Just for extra practice, I'm going to define another function also. This is going to be void again. But I'm going to do some math, some mathematical operation. So I'm going to say now my second function is double. Double is going to be in here just a variable. It's not a data type. I'm going to say double num. Double num. That's it. So then I'm going to give it some argument, again integer, and this is going to be also pointer. I'm going to say num1. And right after that, I'm going to define the function body. So I'm going to say simply asterisk num1. This is going to be my variable. And I'm going to have it times assigned to 2. And I'm going to close it off. So this is my second function. Remember, for every single function we create, we have to create the prototype. For the first one, I'm gonna just copy the function header line. I'm gonna move here, paste it, add semicolon, remove the name, the variable name, but still asterisk must be there. I do the same. I copy the header line of second function. I paste it at the beginning before main. And then again, I remove num1 as well. I'm done. I created prototype for both my function. It's time to call both of them. Where? Inside the main function. I already defined my integer to be num. And then in here, I have get num. And in here, I have num1. So now I'm going to call get num. How do I say it? I simply need to use the exact same name of the function, get num. This is the call inside the main function. And then I can open parentheses. I can add some address operator. And I'm going to say get it from num, get num, and close it with semicolon. I can do the same for the second, which is double num. So I have to say double num. Again, I'm going to open parentheses. I'm going to use the address operator to get access to the address of num because I already defined variable num. So I define both the call functions for both my function. Now I'm going to display the value in num. I'm going to enter a num and then I'm going to double that one. So how do I do it? I'm going to right now say cout, just some note. This, maybe that is the value or anything. And then simply go get the value from num and endl and semicolon. So this is to display the value in the number and return 0. I'm going to minimize to show you the entire code at once before I debug. You can see everything looks fine, no error, nothing, and I'm ready to debug. So I should get the num. I have the option to see in the num, and then that number is going to the second function to be double. So I can just do any number. Suppose I'm going to go pick 3 and then hit enter. So 3 is going to come here and it will be just 3 by like by 2. That's why in here I mentioned just whatever number, double it, multiply by 2 and print it out, which is going to be 6. So I defined two functions. Both my functions are pointer, and then I connected the two pointers in the two function to just exchange some information and take them to the main function and display them through the main function. Any questions so far? Clear for everyone? So far I have like the option in this example to see in some number, but definitely you can just go ahead and define maybe any number inside the code. Instead of having the scene option, you can just define the number inside the code. Considering that, I'm going to go ahead and maybe even practice another example with you to have some constant pointer. Constant pointer means you are not gonna just change the information. Like for example, I'm gonna just show you through the lecture note. Like for example, I'm gonna define the constant pointer to be assigned to this certain value. I cannot change it anymore. So it must go ahead and stay as this variable is. That's what we call it, constant pointer. So PTR is going to be, or pointer, this is a variable name. It could be just anything else. In this example is PTR. You can have it num, you can have it just whatever. It's going to be a constant pointer. So constant pointer, you can just point to a constant number and you never can just point to anything else. So you cannot change it during the process of operation. It's going to always just look at this constant. If it is a constant, it's not going to change. It always can stay as 22 in this example. Another one is dynamic memory allocation. So far I said any variable we are defining automatically without us being asked where we want the address to be for this variable. Computer is going to choose maybe the first availability of the memory for that certain variable. But there are situations, since we do not have access to just say, for example, I need this much RAM of the memory. There are situations I have also no understanding of how much RAM I need. And I might go ahead, define a code, maybe including lots of mathematical operation, maybe reading data from a file, and you are expected to now be able to read data from file from the previous lectures that I taught you. And that file is having a lot of information. In those situations, what if I do not have enough space for storing all those information? And during the process of compilation, I may run out of space and I may get error. And my Visual Studio may just stuck in a certain line of the code, not being able to process and move to the next line. That's why I want you to learn about dynamic memory allocation. Therefore, as an engineer to be in any situation that you have no idea how much space you might need from the memory, the best practice for you is going to be start with borrowing extra space or define one line in your code to get access to more space being assigned to Visual Studio in case needed. So that will guarantee you are not gonna stuck in a certain line or in a certain step of programming just because of lack of memory space. And that's what I'm gonna teach you how you do that right now. So for example, in here, I define maybe some variable to become a pointer, like for example, dptr as a pointer. But I have no idea, I'm going to practice it on Visual Studio as well. I have no idea how much space I might need in order to process this information. Therefore, if I define, for example, this one as an pointer, num as an pointer, and I have no idea how much space I need, then I go ahead and say num being assigned, and that's what we call it, dynamic memory allocator. I must use the keyword new. That's why when I type new, I'm gonna maximize to ensure you can see. As soon as I type new, the color will change to blue. Simply means this word is known for the compiler. So new is a keyword which is helping me to define a dynamic allocated memory, means going ahead and borrow memory from the RAM of the computer, main RAM of the computer in case needed. And right after that, I can go ahead and use, for example, in this case, I do have the data type integer. So I say integer, and then I close it with semicolon. So then in case I need more space, since I do have dynamically allocated memory, it will help me to return the address of memory location, and if needed, it will help me to just have more memory being assigned to this variable. Anytime that I go ahead and use new means anytime I borrow some location or I borrow some more RAM, definitely I must go ahead and delete it. Because if I do not delete that allocated memory or dynamic memory, it will occupy the RAM of the computer for no reason, and it will bring down the speed of the computer, and it will avoid maybe for you using the same computer for other application. Therefore, as soon as you borrow, before closing, just go ahead, use the keyword delete. Delete also is a keyword. Look at here, as soon as I type it, the color changed to blue. Simply means this is also known. So I use, for example, this one, delete, like for example, any in here I use dptr, in here I use fptr, but me in here I'm using num. So I say num, then delete num, because num right now is assigned to allocated memory, then delete it. As soon as you say delete, any dynamic memory become free, and that certain memory can be used for any other application. So we use the delete as a keyword to release the dynamic memory. We use the new as a keyword, as you can see in here, to allocate the memory. Using new, I allocate the memory, and using delete, I release the memory. Make sense? Some feedback, please. So I'm gonna stop it right in here before I add more information, and I'm gonna just help you with any of your question, and I'll come back to continue later. So let's go back to pointer discussion. So far, I'm going to quickly summarize. Anytime that you're going to turn a variable to a pointer, definitely you need to add an asterisk before the variable. And of course, if you're not sure how much memory you need in order to process the entire project or code that you are providing, you may want to use the keyword new in order to allocate the memory And anytime you are using the keyword new to allocate memory for that certain variable, in this case, like in here, I'm using an integer, definitely you have to use the keyword delete in order to release the memory and ensure that still your computer is going to be able to be used for different application. Let's go back to how can I return pointer from a function. So far, look at here. I have defined some pointers in here. In this function, I have defined another pointer in here. Now I'm going to return pointer from function. How do we do that? So remember I said pointer can be like, for example, inside the function as well. And anytime that you are going to return any pointer, still you must use the asterisk. So let's practice how we can return a pointer from a function. So we can go ahead, we can define, for example, some variables like in here. This is going to be the header line of a function, which I have turned it to a prototype. Like, for example, in here, I'm going to define something similar to this. So I'm going to say integer, maybe new num. And then suppose that this is going to be a function. And I'm trying to use it as a later as a return type. If I'm gonna use it as a return type, so I can just define that one. If new num is going to be a function, suppose this is a function, maybe with some information right in here. Then if you wanted to return it, you can return it as integer asterisk, but still you must include, if it is a return type, you must include, as you can see right in here, some parentheses inside the main function. And that's what we call it. We can return a pointer of a function as a just return type inside the main function. So this is all about like the pointer. So pointer can be returned as a function. Pointer also, if you have any pointer function, you can just delete the allocated memory. So if you have any question about the pointer, feel free to ask. Otherwise, I'm going to quickly go ahead and just solve some examples for you and probably give you a quick review from whatever we have discussed so far to ensure that you are going to be ready for your midterm exam. So at this point, I'm going to just stop recording, waiting for you to ask any of your questions. So I just said how we can just go ahead and pass or maybe return some information. Initially, we practiced how to, like, for example, create function. Let's do that from scratch together. Maybe it's better for everybody to start practicing with me. I'm going to start with like hash include from scratch. This will help you to just review everything from scratch with me using this simple example and kind of use it as something that you can remember for your midterm exam as well. So I'm going to start with hash in order to create any code. Hash include from scratch. I'm doing it from scratch. Practice with me. So start with hash include iOS stream. This is how we start our code. First line. Right after that, I'm going to go ahead and say using namespace std. Remember all these steps. Right after that, I'm going to start with int main. And of course, you have to make sure that you do have your parentheses. And right after that, your curly brackets. So this is how we create a template in C++ programming. Can you guys see my screen? Do you mind confirming if you can see my screen? Yeah, perfect. So now we are going to pass some information, but definitely in the process of passing some information from a function to main function, I'm going to even repeat from scratch how to create function, how to define a regular variable and everything. So this simple question or this simple program is going to help you to review all the information from the beginning of the semester. So initially I'm going to start an integer and I'm going to give it a simple variable name to become n, right? Now I simply want to see out or print out information in this one. In order to print out information, we have to use cout, right? Cout and supposed to be an integer. Either you can assign that integer right in here inside the code, or I can say have it as a cin, means as an user interaction. So I'm going to say enter, please enter a num. And then remember using either and L or backslash n, you can move to the next line. So since I said enter a num and I don't have any number assigned to n in here, I have to use cin. And right in here, I'm going to say what is n. These are so far the first few sessions. Now, I'm going to pass some information from a function. Next, let's go ahead first define those functions. So I'm going to define some function. You can always have return 0 right in here to complete your template. Remember I said best practice is creating function after your main function. First function I'm going to create is a void function, right? I'm going to give it a name, make it 01 or make it the 0. This is just a name. You can pick another one. For function, either you have argument or you do not have. In this case, I'm going to define some argument. Anything inside the parentheses could be called parameters. The whole parenthesis is an argument. Information inside is going to be called parameters. My first parameter in here is an integer, and I'm going to give it a name like my num. This is going to be my variable. And I'm going to open and close curly bracket. This is like, for example, a simple function. First line, which is line 15, is considered as the header line of the function. And I can have like this, my num in here, my num. I'm gonna just simply go ahead and give it maybe 0. So this one is and is an argument which I have assigned my argument to 0. Remember, this is the first step of creation of function. Function, we call it function definition. Second step is copy the function header line, move to the beginning of the code, ensure after namespace, and still before main paste it, add semicolon, and remove the variable name. Still, you must maintain the data type and any other symbol, such as, for example, if it's a pointer, you must still keep the asterisk. Or if it is array, which is going to be maybe a later lesson that we are going to practice, you must keep the array symbol. But in this case, it's just a regular variable, so just keep the data type. I'm done with the prototype for the function. I'm going to create another function as well. This second function I'm going to pass by reference. So I'm going to say void. This is another function for this one. So I'm going to say this is passing by value. I leave you a note. This is passing by value. For the passing by value, before I move to another one more time, I created the function. I defined the value to my variable. I created my prototype, and definitely, so this is the passing by value. This is the prototype for it, and I must return it. How do I return it? I'm going to leave a note in here. Passing by value. I'm going to return it as, what's the name? Name is make it 0. So I have to return it as make it 0. And I'm passing, right? Open parentheses. The only variable I have is n. So this is going to be my call function, or a step 3, which is passing by value, because I do have a value, right? Now, I'm gonna give you another example, which is passing by reference. These are the content of what we have discussed today. Let's practice another function to pass by reference. Passing by reference. How do I do it? I'm going to define another void function. This time I'm going to give it, this is make it 0. This time I'm going to say make it 0, 1, make it 0, 1, and I'm going to show you what's the difference between passing by value, passing by reference, and of course passing by pointer. The 3 concepts that we have discussed today: passing by value, passing by reference, and passing by pointer. That's why I'm giving you this example. I'm going to give it another argument in here, very similar, still integer, but since this is passing by reference means the address of this one should be linked to another address. That's why we say reference. Therefore, I have to use address operator. And then it was my nom. Still, I'm going to say my nom. Same. My nom is going to be my variable. And I can go ahead. So far, you notice. This one is passing by value. So I don't add any syntax in here. I just say my nom. But since I'm going to reference, I must add a address operator to be considered as passing by reference. So this one will change the argument value outside n. So this will change the argument value outside n. That's the difference, right? But if I'm having it with like passing by value, it will not impact the argument outside. Whatever I have in here, it will not impact. This will not impact outside the argument. But this one will change. I can also add this one to here. So how do I do it? This is a command. In order to not to change it, still I can do the exact same thing. It's still my nom, and I'm still assigning it to 0. But since this one has a reference, this AND operator, this will change the argument value outside n. But this one, since I don't have address operator, it won't change it outside n. So I have the second function. I did the first step of it. In order to create the function prototype, I have to come back here. I have to add semicolon. Again, I must remove the variable name, but since this is a reference, it has address operator, I must still keep the address operator. And in order to have the function call, I have to go inside. So remember, I'm gonna still leave you a comment here. How to pass, I'm gonna say passing by reference. How to pass by reference. How do I do it? Again, I'm gonna use the exact same name. This one is making 0, make it 0, 1. And again, I'm going to open parentheses. The only difference in here is just anything inside parentheses has address operator, but still I keep it as n and I close it. So the call function is exactly as it was for passing by reference and passing by value. So let's create another function to practice passing by pointer. So again, I'm going to say void. Again, I'm going to say make it 0. But this time, I'm going to give it 2 open parentheses. Still, I'm going to use an integer. The only difference in here is instead of having like a regular variable here or a variable by reference in here, I'm going to create a pointer and call it my nom. Again, all I'm going to do is exactly as I did in there. But the only difference Remember, anytime a variable is a pointer, I must keep using it as pointer. Otherwise, I'm going to get error. So I can, again, do the same thing, assign it to 0. But what will happen in here, I'm going to leave you a note. First, this is passing by pointer. Passing by pointer. And then in here, I'm going to say, what is the difference? If I pass by pointer, so it will change the argument value outside. So it will change this line, my num, it will change the argument value outside the n. And there is another difference. And definitely it is going to dereference the pointer. Simply means it is dereferencing the pointer. So now I can go ahead again, just copy this line, move to here. And remember, since this is pointer, I must keep the asterisk and only remove the variable name. And still I need to call it. I'm going to leave you a message here, passing by pointer. So passing by pointer, I must pay attention. Again, use the same name, but this one was make it 02. I think it was make it 02. Yep. So I have to say make it 02. Again, open parenthesis. This is make it 02. Make it 02. There should be some, let me use exactly the same name. Oh, no, not this one. Same name in here to avoid error. So make it 02. And right after that, I'm gonna just call it, like, for example, since this one has a pointer, I must include address operator and then n. That's the only difference in here in order to avoid any error. So this is how do I pass by pointer. If I have a variable being a pointer, I must use address operator. If I have a variable, it is just a reference. I just use the variable name, and regular variable is just as always. Now let me just add some display message, then cout just some message for me, and let's say the value of n, because I'm going to just see out the value of n. So the value of n is, and then I have to go ahead and read n and then handle. So I have practiced almost everything I have discussed in lecture 7, which is pointed in a single example. I started with just a basic template for the code, defining some variable inside the main, defining 3 different functions to practice definition of function one more time, and each time creating prototype right in here for like every single function and the call function inside the main, and of course passing by value, passing by reference, passing by pointer to see the difference between them. And everything looks fine, no error, nothing, so I can go ahead and debug. I'm waiting for the debugger. So first thing which is coming up is please enter a number. Suppose I'm going to use 5. I hit enter. So remember, the value of n is not supposed to change outside the n. Regardless of whatever number I enter, I keep getting only 0. So that's why we pass always 0 from the function to the main. And regardless of whatever we get in here as a scene, whatever I put in here as a scene, still it should go right after that. It should go read either of this and it will return 0. Any question? So in this example, I'm gonna just show you how to use not only pointer and address operator, definitely you can use conditional statement as well. So start with hash include. Right after that, again, using namespace, std, and int main parentheses, and right after that, your curly bracket. So I'm starting to implement everything for this one only inside the main. So I'm not going to create any extra function. Instead, I'm going to give you some conditional statement. So far, you have been introduced to another data type like float, like double, right? So float and double, those are like data types that anytime that you have even decimal point, you can use them. So I'm going to use float. I'm going to define my variable to be my float, or you can do like any other variable. And I'm going to assign it to a certain number. Suppose I'm going to assign it to 55. Right after that, remember I said when we are going to use a pointer, I'm going to say float asterisk, then I'm gonna give it a pointer. I'm gonna call it simply PTR, and I'm gonna assign my PTR to be assigned to the address of my float. In order to do so, remember we have to use and operator and then exact same name, which is my float, and close it with semicolon. So initially define my float, then I define a pointer to be assigned to the address of my float. Right now, I'm gonna just display some message, and I'm gonna say, like for example, at, I can use at PTR. I have to read PTR, which is a variable right in here. At PTR, I'm gonna just have the value. This should be the same value as my float. I'm going to have the value my float, or I'm going to have the value asterisk PTR, because right now both of them are the same. Definitely I can use either. So I can say the value, and then I can say asterisk PTR, and then I can have and right? Right after that, I'm going to assign my float to a different number. So I would say float, my float, the same variable. This time instead of 55, I'm going to give it maybe 155 or whatever number. And I'm going to do the same. I'm going to repeat this part. So I just copy and paste for the sake of time. Still, it's the same, let's say variable, but this one, I'm going to call it my float 1. That's my float 1, and I'm going to assign it to the address of my float 1. I'm going to do the same thing in here, cout. Now I'm going to say at, maybe another PTR again, but this time is PTR. I'm going to call also this one PTR1 to make sure you are not confusing these two together. At PTR1, you can give it any other name. I'm going to have the value, and then I'm going to have this one to be asterisk. I called it PTR1. Definitely in here also I have to say PTR1 and then and L. Now, I defined 4 variables, 2 regular and 2 pointers. And now it's time I'm going to put them inside an if and else. So I have to start with if my PTR, which is going to be a pointer, definitely I must keep using asterisk. If my PTR is greater than asterisk PTR1, if this one is greater than this one, then I want some message. Then cout, my float is greater than my float 1. Cout, my float is greater than my float 1. and simply end L. This is one cout, else. Remember how we practice conditional statement? Else, I want another message, cout. My float 1 is greater than. I can just go ahead, copy this. My float 1 is greater than my float, right? And then end L. That's it. And you can say return 0 or you can avoid it. It won't hurt if you avoid it in here. So I'm going to minimize to show the entire code. What I did in here, I defined a couple of in here variables, 2 of them regular, 2 of them pointer. The pointer one is assigned to the address of the regular variables. I display those messages to show the value in each of these variables, and I simply want to just look at the conditional statement and compare them. So this is how we compare two pointer. How do I compare them? Using mathematical operation. I can put them inside the if also statement, compare them, and see which one is greater than the other one. Let's debug. So first I have to just please enter a num. Oh no, this is like actually the previous one. I have to just go ahead one more time, debug it. For some reason it's stuck in the previous one. That's why it's giving me the C in. Okay, then I'm gonna close this one. And I'm gonna close this one to avoid that error. I had a couple of .cpp, that's why it's giving me error. If it doesn't work, the code is 100% correct, but it is stuck in the other .cpp. So I have to just go ahead and define a new project because it is stuck in the previous one. So now if I just put that right in here, the error should be gone. Let's see. Yep, here we go. So it is just processing from line 6 first in here at this address. So it's looking at the pointer address. This is the address. The number, the value at this address, which is at asterisk PTR, the value is 55, which is like my float. And then it is looking at line 4, line 12. In line 12 at PTR1, the number start is 155. Then it will look at the conditional statement and it will compare the content of like my float and my float 1 to figure out which one is greater. Since my float 1 is 155, therefore it is saying my float 1. So it is just passing the if and it is displaying the else condition. Hopefully this is clear for everybody. Any question?